Hello and welcome to episode number 307 of the Armin Show podcast, which has been improving by the day. On this episode, we have the author of Brainscapes. It is Dr. Rebecca Schwarlose of Washington University. She is a cognitive neuroscientist, and we are going to be learning a little bit about brain maps. Rebecca, welcome to the show.
Thank you, Armin. So good to be here.
I'm glad to have you on here on this show, which has been developing over time into cool things. Now, before we get into the content of the book, first, I like the concept of brainscapes and maps and how we can possibly reverse engineer those later on. But how did you get into the field of cognitive neuroscience in the first place?
I don't know. I think it's sort of called to me. I've always been really interested in the brain, really interested in our minds. And cognitive neuroscience is this beautiful intersection between the two, where you can kind of straddle those lines and think both about the brain as a physical entity and think about how our mind works and all of the wonderful tidbits we learn from psychology and try to put those things together.
That's cool. Now, I wanted to start this episode by giving a shout out to Sally Fry Schwarzlose, who is your mother of past remembrance and a big part of the basis behind the energy for the book. And the people behind us are what cause us to do things. Can you tell us all a little bit about Sally Fry?
That's lovely. Thank you for asking. My mother was always my inspiration and kind of role model. She was a children's librarian. She loved children. She loved stories. And she was just wonderful at reaching out to people. But what I really learned from her that I brought to the writing of this book was just a kind of ability to retain a sort of childlike fascination with the world and an openness to, the way things are, rather than looking at the world as, what should they be like and how should everyone else be, kind of accepting things the way they are and sort of looking beneath the surface, saying like, why are things the way they are, and understanding it and accepting it and seeing the beauty in how things and people are. So I tried to channel that for the book. She passed away from cancer while I was writing the book. And I was very grateful that she was able to read a late draft, not the very final draft, but she was able to read it and she knew it was going to be published. And that meant a lot to her and to me to share that with her.
That is cool. She is part of the early step in a map that led to your current moment. That's a neat thing.
Well, I actually wrote about her as well, because she had no sense of smell. She was born without a sense of smell. So she wound up being kind of featured as well as a little story of somebody who had been born and never experienced a particular sensory modality.
I like that concept when you brought it up, because I always think a good chunk of, not almost everybody misses some elements of the whole experience. We have our own experience. We might have 80% of all the absorption of sensory stimuli that is in total, and somebody else has a different 80% or some portion. And so we can relate on the things that we have similar, but then there's pieces that we'll never know. Or so, also another thing I think about is like visually, if you go into a new city, some people, they're real estate focused, so all they see is buildings. Some people are architecture, so all they see is that. And so we're only taking in a certain amount, but that's okay, because that's like our forte a bit. That's pretty cool. Shout outs to Sal. Now, I wanted to throw in one. You had an acknowledgement to Michael Graziano. He has been a past guest on the show, talked about consciousness. Do you look into consciousness as well when you're looking at the brain, or not so much?
So there are some neuroscientists who really focus specifically on consciousness, and I am not brave enough to be one of them. But I do think that much of what I discuss in the book is it's the foundations of consciousness. I mean, so much of obviously what kind of it's discussing how these brain maps that I describe and the neural processes that I describe sort of lead to the what we perceive, how we take, as you said, kind of a bustling world and sort of skim it down into this kind of distillation that we consciously perceive. So consciousness is very much, I think, a part of the book without me tackling the big question of what exactly it is. But I think it's such an exciting and crucial part of everything we think about when we think about how the brain works.
I was just thinking of gestures when I was making a movement there a couple episodes ago. We were talking about gestures and how it's so valuable when you communicate. So I'll be doing a lot of them, frankly. Now, you talk about maps right from the beginning and how they are built into our brain. Why is it such a relevant point? What are these maps? Some people they've never heard this concept.
Right. And, part of my goal with the book was to introduce them in a way that would be comprehensible, because at first glance, it just sounds weird. How could you possibly have a map in your brain? And some people maybe have come across the idea in an introductory psychology class, maybe in college, but it may still be kind of hard to really intuitively understand what it is. So the first chapter of the book is really walking through exactly what it is. And what it is, as in popular science, we often, if you follow the brain in popular science, you often hear about brain areas. And so probably your viewers will be familiar with the idea that different brain areas, different bits of brain have kind of specializations. They sort of specialize in processing different types of information and carrying out different sorts of computations. And if somebody has like a stroke or other type of brain damage that destroys one of, particular area, they'll have particular problems based on what that area did. So that's kind of a fundamental kind of underpinning of cognitive neuroscience and neuroscience in general. So what brain maps are is when you take one of these areas that I mentioned and you look within it. So you start to look inside of an area at how it is organized. Oftentimes that organization is in fact a literal map, a spatial representation across the surface of your brain or within the structures inside your brain that reflects what you're seeing, what you're perceiving, feeling on your skin, the space around you. So as wild as it is, what I'm saying is that there's a point-to-point kind of relationship between, a spot in, a visual map at the back of your brain and a spot in your visual field where you're looking. And so what's happening is, what you're seeing, what your eyeballs are detecting is coming into your eyeballs. But in terms of what you perceive, it's determined by how that representation in that back of the brain. And that map, that correspondence between where activity in the brain is representing and what it's representing forms maps that you can actually see with functional MRI, which is a type of brain scan, or you can even stain a brain and visually see the map by converting activity that the brain has been doing into something that's visual that you can see. So there are some pictures in the book of these actual brain maps that in one case show what an animal was looking at. So that information is there. And that organization is not just kind of amazing and cool in and of itself, but it's really informative for us first in terms of explaining how we think and perceive, because these maps and the kind of quirks that they have are shaping how we perceive and how we remember and how we imagine. So they are profoundly important. Right.
They're built in there and they end up representing how we talk or where we're more likely to head towards. I always think of deconstruction in a form. How did we reverse engineer toward these maps so that we could see that they were there? Because before we know something, we don't know something.
Yes. Yeah. So how did we discover them? How did we? Yes. Mm-hmm. So actually I think the kind of earliest discovery would have been the motor cortex, which is the part of the brain that like the kind of last part of the brain that then goes on to send signals to your muscles and causes you to move, allows you to do all the wonderful things that your body can do. And so this motor cortex has a map layout that's grossly organized according to your body. And so, there's an area that is kind of in charge of controlling hand movements or things that are primarily, yes. And there's an area for facial movements, including speech, and an area for wiggling your toes. And so these different kind of zones were first discovered by a neurologist who was studying patients. And this is a general theme in neuroscience, that most discoveries come from patients who are having problems. And in this case, he was studying patients with epilepsy or who were experiencing seizures. And he noticed that in certain patients, they would have seizures. The seizures would travel, they would start somewhere. Like, there's a story in the book, you're like one person who just like, he was eating breakfast and his thumb starts doing this. And then the movement starts to travel, and it would travel through the body across different people. It might start in a different part of the body, but then the movement would like spread in a very consistent order. And based on that order, this neurologist was able to kind of guess that there was a map inside the brain, that activity, as it kind of went out of control in a seizure, that it would spread across the surface of the brain. And as a result, the movement would spread across the surface of the body.
I liked that concept because when I saw it, it's another, I always like when things go to another level. So if someone had a seizure, there were doctors that would treat that and they don't, okay, they had a seizure. But the next level is, wait a minute, we're starting to see patterns in it's passing on this way. It's moving. Wait a minute, does that relate to something? Every time you do something repetitively or a lot, you start to really get a sense of something deeper. And then if you do that and you look at that a lot, you get a sense of something. The power of repetition in some forms. I like these kind of personality or life concepts to link back to things. Seizures are, yes, I noticed that in the book that seizure patterns pinpoint damage in the brain is how you mentioned it there. That's interesting. Now, so when we find these kind of movements, what does that represent in the brain? That's how motor function travels, or what does that tell us about the brain?
It tells us about how the brain represents the movements that we make, and in doing so helps us carry them out. And so speaking of Dr. Graziano, I describe in the book some seminal work that he and his colleagues did, where they could stimulate a particular neuron in this motor map, and they would watch the animal do this totally, so in this case, it would be like a monkey, and the monkey would just kind of carry out this motion that involved multiple muscles and was very kind of smooth and elegant. And it would just happen automatically every time that neuron was excited. And so that idea that, that representation, that neuron and the sets of neurons around it that are kind of representing certain actions, those are kind of helping. It's both a way that our brain can carry out important and the motions that we use the most and the ones that we rely on for survival, like eating, so these motions tend to be things like eating or defending yourself from attack, reaching, stepping. Yeah, exactly. So
myself.
Yeah. So there are things that an animal, or, for our case, would be humans would do a lot, or things that would be important for survival. And having that encoded in our brain makes it easier for us to quickly and easily and elegantly carry out these actions.
That makes sense. Now, this is in the motor cortex. Another thing that comes to my mind was visually, you had a section about smell, which is related to what we mentioned earlier. Lack of smell can be something. Smell being encoded for like a benzaldehyde, I think, and other molecules and the smells that come with them, as there's little regions that are lighted up for that smell, and there's little regions of neurons that are lighted up for that smell. Is that also a map?
That's a great question. So there are, I kind of draw this distinction in my book about what are considered literal maps, topographic maps, they're called in neuroscience, of vision and also audition. So hearing has maps based on frequency that are continuous. And, with somatosensory, with touch, we have body surface maps. Then you get into the other kinds of things that we do. And instead of being continuous, we want to know, like, what is something? So in a sense, we're trying to categorize it, which is different than sort of perceiving in that early raw form with visual location or with frequency. And so for these kinds of, I call them maps, but they're a little different. They're really kind of like zones. And usually these zones sort of together form a larger sort of, they're organized amongst themselves in a systematic fashion that you might call a map, but they're like neighborhoods. They're neighborhoods that are dedicated to processing really important things in your world. So from the visual perspective, we have, for example, areas of the brain that are dedicated to representing faces that we see. And those areas are crucial for allowing us to recognize a face, even a very familiar face or our own face in the mirror. And if damage takes place, then we lose that ability. And similarly with smell, so there are some areas that have been found in animals that are like zones that are specifically kind of either kind of recognizing scents that are indicating that a predator is around, and then activity there initiates this kind of, oh gosh, I better run or I better freeze activity. Or, there's another area that, has to do with like picking up pheromones from the opposite sex. And so that starts a whole kind of mating actions. So these are some of the ways in which our brain is sort of, or at least the animal brain is able to translate even like a smell an animal's never smelled before of a predator that it's never met into an appropriate action. So those are kind of pseudo maps. They're neighborhoods, but I think they illustrate the same point. They give us the same tools for working and interacting in our world, and in knowing what they are and seeing them, it helps us to understand sort of our own existence and what is important for us.
Mm-hmm. When I saw that, I thought of this one book. I never read it, but it was about smells and how we're able to separate them all, and they have like specific chemicals that's that smell, and this is that smell, and we have like I don't know how many hundred of them, something like that. It's interesting to think of how much we associate those with certain moments in our existence almost, which is funny. Like when I was little, I played Nintendo, and there was like a plastic smell from the styrofoam, and so whenever I'd smell that later on, boom, instantly thinking of playing Nintendo, which is kind of funny.
Yeah, smell is interestingly linked to memory in a deep and profound way. Which is why people who lose their sense of smell later in life can be really, really depressed and severely impacted by it, because they lose that kind of extra level of experiencing the world that they may not have even been consciously aware of.
It was part of it. Take it for granted. And also no
Yes.
cinnamon. Where's cinnamon now? It's gone. That's pretty good. Now, there's smell and there's the motor cortex as far as movement. What about the first one that came to mind to me is always like thought patterns. Are there maps of our thought patterns in place as well?
That's a great question. And so in the later chapters of the book, what I try to explain is how we actually harness these maps, which are usually, they're laid down very early in life. And they don't change a lot as we grow. Their general organization stays pretty similar throughout childhood and adulthood. And so, how do we kind of then learn to represent more complicated concepts and thoughts, and how are those, are these maps related or important for thinking? And what I discuss is that they're not the whole story. So there are other areas of the brain that are not organized in maps. They are what I call, they have like a population code, a code organization, so that there's, it's really like the pattern. They're all mixed up together, and two neighboring neurons might be representing very different things. But it's the pattern of activity across all of them that tells us information. Whereas in a map, you have two neurons next to each other, they're doing similar things, and that where exactly they are tells us something about what they're representing. And the combination, so the codes are awesome for representing new things because they give us total flexibility to learn new associations. And the maps give us the stability, this stable representation of space and of sensation that we can then integrate these kind of new ideas with. And so actually we do, using as areas of the brain that have codes, we are also harnessing topographic brain maps, when we think about things like numbers or time, or even when you hear a word, you actually, like if you hear the word grab, a part of your motor cortex that is engaged in hand movements will be active as well. So, if you see a hand, then an part of your that you will get activation there. So you have this way in which thoughts, like meaning, echoes within your brain maps, and it not just one, but many at the same time, and not just in me, but also in you, so that there's this consistency in that representation.
That is a cool thing. It made me think of this one book I read a long time ago about if you pretend you're swinging a tennis racket in your mind, you're somewhat training your ability to swing a tennis racket, even though you're not swinging your tennis racket.
Yeah, absolutely. And I talk about in the book how imagination, you can see imagination in brain maps, and that what you're imagining, the contents of what you're imagining, the way that they activate your brain maps is very similar. It's like a weaker version of what would happen in your brain maps if you were actually doing or seeing or experiencing that thing that you're imagining. So it may well be true that I'm not in, there's a whole sports field where they might say, imagine and then you'll get better, and there could very well be a neural basis for that. That's not my area, but definitely similar parts of the brain get roped into representing both what you see and what you imagine.
Makes sense.
And I think that's super cool because it also reminds us that what we are able to perceive constrains what we're able to imagine. And it's these brain maps that help explain why that is. That I thought about this a lot with my mother, because she would try to have me describe smell. And how do you describe the sense of smell, or the smell of a rose or of an outhouse to someone who's never smelled, and try to get them to know what that's like. They can't imagine it if they don't have the neural architecture to produce that imagery.
It's hard to relate it. What does cinnamon smell like? Well, it's oatmeal. You put it on, maybe it tastes good. I don't know. That's true. That's very hard to translate. I like that you brought that up about the connection between the imagining and it actually is processing, and then that relates to it's sort of like our abilities almost. The expanse of what we are thinking here is connected to the expanse of what we're able to do externally. I like that. Do you like to think of things in an open-ended framework in existence? This is like a personality type question. Or do you like to be more limited in structure and work within confines?
That's a good question. I actually am a little bit of both. I like to dig deep. And in fact, I usually have to be like, okay, stop researching. Stop researching this thing. You've spent enough time. Move on to the next thing. So I love to keep digging. But then I also really love kind of to sit back and reflect on how all those various holes I've dug link together, and try to think about the big picture. And that kind of makes the digging more exhilarating as well, because then it's all part of a kind of a grander story. And so I think we should always be thinking, we should always be digging, because I think digging is how we get answers. But if we're not also thinking about how it's fitting into the larger perspective of kind of our world, our science, how the brain works, then we could be digging in the wrong place, or not really able to discover how what we find is relevant in the big picture.
I think about this concept often. It's sort of like there's an expansion period and then there's a consolidation period, and if those are not happening as like waves that are sinusoidal, classic word, then we are limited in our ability to grow. That's one thing I think about. Now, maps, as far as applicability, how could the average individual either use knowledge of brain maps for themselves? Is it something they should use in some actual actionable way, or is it something in the back of their mind that can bring peace or understanding?
So I specifically wrote the book not as kind of a how-to book. I wanted to, because we've lived in our brains, and in some way what I wanted to do was explain why your brain is the way that it is. I think there's an incredible power, and sort of it's empowering to know better how your mind works, why it works the way that it does. And it's just thrilling, because I think when you step back and you sort of, we've lived with our perceptual experience as it is from birth, and it's just taken for granted. But if you understand how your specific, rather small amount of brain space is, and the constraints that places, it's like, you could fit it inside a hat and it's supposed to represent a whole world. How do we do that? Well, we have a lot of tricks. And one of them is brain maps. So I think, though, seeing how that shapes how we think and how we move and how we act is, I think it's exhilarating, and I want to share that with people. And then, secondarily, a couple of things that I talk about in the book that I would like to raise awareness of. One is about the kind of importance of very early life on the development of brain maps and in the development of the brain in general. And so I think, I'm a parent. You see your kid, and it's kind of amazing to watch them grow, but there's so much more under the hood happening. And actually, baby brains are they're like superheroes. They're superpowers. They can do almost anything. They're just incredibly plastic, flexible. And so kind of appreciating how they at that age are learning and how that shapes their later kind of brain organization and capabilities is really, I think, valuable for us as parents and also as a society, because I think that we could be investing a lot more in helping parents and families give children the kind of opportunities and experiences that will help give them the most kind of bang for their buck later when they have to go and learn to do other more complicated things. And then the other thing that I really wanted to get at is I have a chapter about brain-computer interfaces. So essentially is something that has been around for a while, but is kind of rapidly growing and becoming more mainstream, that there are technological advances in trying to have brains and computers talk to one another. And so that you could either read information out of someone's brain, or you could convey information into someone's brain through a device. And brain maps explain how that's possible. And they also explain the ways in which that's the opportunities there are limited. And so I spend a chapter talking about why BCIs work, kind of where things are now with them, the challenges that they face, but also the ways in which they are certainly going to overcome them. And then in the end, we need to be thinking as a society that this is coming, this is coming on some front, whether it's going to involve actually having electrodes inside our brains, or whether it's going to involve something sitting on our scalp, it's coming. And it's not far away. It's something that we need to be anticipating and talking about as a society, about the ethics and, what kind of regulations we want to place on this technology before it's already widespread, because it's right now only in the hands of corporations. And if we don't do something, then we're kind of leaving all the choices up to them.
That's true. Is it fair to say that artificial intelligence systems are, even at this current moment, partially reverse engineering our thought processes and or thought maps already today for purchases and things of that nature?
Yes, absolutely. So already, right, because of the way that our web browsers and our social media is tracking the choices that we make, or our preferred shopper card that keeps track of what we buy. Already, machine learning, which is a branch of artificial intelligence, is incredibly good at figuring out, what we're going to buy next, which can be useful, but also whether we're depressed, whether we have Parkinson's disease, whether we're pregnant, things that we, may not even know ourselves, and certainly don't want a corporation to know. And so already these problems are here, but they're going to get bigger if we kind of throw in the power of neural data combined with these machine learning algorithms.
Yeah, that makes sense. I logged into a system online and it told me I was pregnant. So I knew it was wrong. Error. You've made a mistake, computer. No, it didn't tell me that. That would be off. Classic. Now, two things come to mind here. Well, one was that reverse engineering. Two is the plasticity we mentioned earlier. It made me think of, I always wonder about like, what's the cutoff? What age would you say is the cutoff where, let's say, 80% or some majority portion of a person's base thought patterns, personality is fixed in place, and there'll be a little adjustment on top, but pretty much it's cleared out? What age range would you say that's in?
That's a very great and complicated question. In terms of in terms of like higher level kind of like behavioral patterns that to some degree we can talk about in terms of personality, like whether you respond to certain situations with anger or anxiety or things that I think we have very much the power to develop that throughout life. And as we change our actions, we can change sort of the neural circuits through which we sort of automate our reaction to the world. So we have, I think in that respect, we have quite a considerable power to change. I think in terms of brain maps or the kind of organization of all of those parts of the brain, that some of that is, there's even aspects of our kind of like our hormonal neuroendocrine system and our layouts that is kind of getting solidified in the first week or two of life. I mean, very early. So it really depends. These critical periods, as they call them, in psychology, they are different for different functions. And that's because the brain is kind of very dynamically growing and the child's experience is very dynamically kind of evolving. And so different neural processes sort of crystallize at different ages. But in terms of these brain maps, a lot of it happens really in the first few months of life. The organization of their brain is really dramatically undergoing change. And so that even later in their first year of life, things are more stable. And of course, then they're doing more refining. So there's other things that they, for example, they're being exposed to new things and learning new things. But the idea that, even in that first week or two of life, they are sucking so much information out of the world around them, out of the things that they touch and the things that they hear. And this is helping them to kind of manufacture and create and tweak their brains in such a way as to be hopefully best adapted to life in that world. And this is not just great for a baby who doesn't have any health problems, but it's usually great for babies who, for example, if you have a baby who's born blind, this gives babies who are born blind and who that blindness cannot be fixed, the opportunity to really radically kind of redistrict and reorganize the visual portions of their brain in ways that they are going to be able to use for the rest of their lives.
That makes sense. I always think about the times where that element is paused, or not paused, but the changes will be limited. There's this one concept that it's kind of a sad concept, but that there's always one day that's the last time a parent like carried a child. They didn't know it, but then like that was the last time. And then after that, they just never did that. And so then I think about certain points in life where this quality of personality or this amount of reaching out, it's like that was the point. So it's like a cutoff point I think about in the background, which is a fair consideration of sorts. Now, one thing I want to counter is, what about, are there any challenges in the field of brain maps, or challenges to the field, or any difficulties you have had, or controversy, these kinds of things? I never go into the opposite side. What's the difficulties here, or is there any views against it or such?
Well, it's funny because brain maps are the old news that stays new. I mean, we've known about at least some brain maps since the 1800s. And so in some ways it's like, brain maps, yeah, we all know about them. But what's kind of amazing, and whereas there are newer features of the brain that they're not new, they've always been there, but we're learning a lot more about how to think about the brain as a series of kind of this complex network of kind of hierarchical, multiple connections. And we didn't have the capacity to be able to think of it that way, both technologically and computationally, even 50 years ago, to the degree that we can now. But what's amazing is that as we keep, it's a story that keeps on popping up, because as new brain areas are investigated, we keep finding these organizations, these maps within these areas. And so it's just, and we find them not just in humans, we find them in just an incredible variety of species, including rodents and, bugs and birds. They're just everywhere in life. So it's, it's a story that keeps giving, but it's not always the story that the scientist is not the new hotness in some ways. And I would say also the balance between where the brain, like codes versus maps, the line between these things is not always clear. And in fact, when you zoom in very, very close into a map, often there's kind of like this amazing micro architecture to the organization within a map. And it's hard to describe without pictures. There's some pictures in the book that are cool. It's kind of like thinking about it as sort of like thinking about physics. When you get really, really small, particles get weird. But the point is that there are ways in which even maps kind of have deeply embedded within them at their core, they have codes. So the balance between those things is kind of fluid, and it's not a clear distinction.
It's like computer chips, and when you get super duper small, and then like the electricity through a transistor, and then it like affects the other, it's like one atom thick borders, and now you're dealing with a different level of physics like you're describing here. That's pretty nifty. The changes at really small levels that we don't know about, but later on we'll have some sort of architecture for that, micro architecture. What is something you would want all the listeners to know as a takeaway about brain maps that would put them at a greater state of understanding?
I truly hope, and I say this at the end of the book, I mean, I think my goal is that the readers who read this book will come away feeling enlightened about their own kind of place in the world, the way that their mind is shaped by their physical experience, and why they think and feel the way they do, that they'll notice features of their experience that they hadn't noticed before. And, I think in some way there's like really a grander story to how brain maps, which arise because of physical constraints, our brain having to be really tiny and energy efficient and still very powerful. Again, inside the hat. Yeah. So given that, we really harness tools that are based very much in our physical world. And so, I think in some ways, seeing how we are sort of shaped by our physical world and experiences in terms of our brains, and realizing that there's a profound universality to this across species and across individuals. So these are features that you and I share, and that we also share with snakes. That is, I think, really beautiful and amazing. And I think it's something that you can come away with feeling like you have learned about your experience.
We are all connected in that form. Last thing I want to check, do you have any scientists you look to who guide your thinking, or you'll just like the research that they're doing in some category? Is there any people that come to mind as like representative or that you like?
Oh man, I think I'm afraid to even answer that question. There are so many scientists that I admire. And honestly, the way that I think science usually works is that you have to be kind of careful about crediting one person with any particular advance, because there is such a network of kind of coordination, working together to make new discoveries, and then on top of it, building upon the results of others. So I'm gonna pass on that question and just say that I have admiration for many scientists.
That makes sense. And the point you brought up reminded me, I recently read that more papers today are multi-author than they were like 40 years ago. It's much more collaborative mixing of sorts, kind of like the Santa Fe Institute, and it's multidisciplinary mixing, which is cool. Nice. Dr. Rebecca Schwarlose, I would like to thank you for having been on this episode of the show and discussing Brainscapes and related concepts.
Well, thank you so much, Armin. It was just delightful. I enjoyed it.
I enjoyed it as well. And we are out.